The figure shown on the right is composed of two squares. The smaller square has a side length of x. The side length of the larger square measures twice that of the smaller square. Which expression accurately represents the area of the entire figure? So for this problem, let's first write down all the sides. They gave us x right here, so we can also write x for the other three sides of the smaller square. Since the side length of the larger square measures twice that of the smaller square, that means for the larger square, the side lengths are 2x. And because we already know that the top part right here for the smaller square is x, we just need to highlight this part and write x, knowing that if we combine them, it's x plus x or 2x. Remember, x plus x is not x squared, but 2x. Okay, so now we need to find the area of the entire figure. We just need to combine them, right? Because we need to find the total. Okay, so first we can find the area of the smaller square. Which is x times x, or x squared. And then we will find the area of the larger square. And again, we need to multiply side by side, so that would be 2x times 2x. If we were to use commutative property of multiplication, we can first take out the parentheses and write 2 times x times 2 times x. And then move the factors around and we get 2 times 2 times x times x. Okay, that gives us 4x squared. So we just need to combine these two areas to get the total area of the figure. That would be x squared plus 4x squared. Or if you think about it, the invisible coefficient in front of the first term would be 1. And to combine like terms, we keep the variable and the exponent. We only add the coefficients if they are like terms. Since these two have the same base, which is x, and the same exponent, which is 2, we just need to add the coefficient 1 and 4. That gives us 5x squared. So that means the combined area would be 5x squared. Now if you look at the choices, none of them shows the final answer, but we can still solve them to see which one is 5x squared. If you look at B, we already know that's not true because that gives us 3x squared, so it doesn't work. So we can cross that out. And then for A, we also know it doesn't work because we don't see any exponent of 2 but only 1. So even if we combine all the like terms, you know that you are going to get some number times x, and let's just solve it anyway. We have 4 x's right there, and then 3 of the 2 x's. So just add all the numbers if you don't want to do multiplication. So 1 plus 1 plus 2 plus 2 plus 2 plus 1 plus 1, that would be 6 plus 4, so 10x. It still doesn't work. Well, if you look at C, you know that you can multiply 2x and 3x. Applying commutative property of multiplication again, we know that for C, 2x times 3x is basically 2 times 3 times x times x. That would be 6x squared. And we still need to subtract x squared from 6x squared. That gives us 5x squared. So that means C is the answer. To prove D is wrong, I will show you why. So for D, we have x squared times 2x raised to the second power. So think of this as you are multiplying 2x twice. Think of 2x as a factor. Alright? So that way you know that this is basically x squared times 2 times x times 2 times x. If you rearrange the factors, you will get 2 times 2, which is 4, x times x, which is x squared, and then I'm going to bring down this x squared here too. Well, this is something you will learn in 8th grade, but you can also think of this as you are multiplying x 4 times, because x squared is x times x. So I don't want to go over the exponent rules right now, but you can still find your answer. So this would give you 4 times x to the 4th power, which is not the correct answer, and that's why we have to eliminate D.